In 1891, newspapers reported the story of James Bartley, a whaler who was swallowed whole by his prey. Supposedly, Bartley spent as long as 36 hours in the belly of the beast before his crew caught the whales and rescued their crewmate, and this tale is far from unique. Various novels, myths, and religious texts depict figures swallowed at sea, with some even making a home for themselves in the creature's cavernous mouths. Unfortunately, if someone actually were swallowed by a whale, they would likely be crushed. But if they somehow survived, they might have a chance to escape during the captor's bathroom break. Whales are frequently surfaced to take in air and let out a massive plumes of waste. And while swimming in the slowly might seem more disgusting than living in these creatures, whale's poop is much more desirable than it may seem. In fact, it may be one of the most important substances in the ocean and the world. To understand why, we need to look at some of the ocean's most ubiquitous organisms, phytoplankton. These creatures survive off sunlight, carbon dioxide, and nutrients like phosphates, nitrogen, and iron. And since the ocean surface waters generally have an abundance of these resources, phytoplanktons are everywhere. A single drop of seawater can contain certain of these creatures, and the phytoplankton blooms are large enough to be seen from space. These phytoplankton then become food for countless microscopic creatures, including copepods and krill, which in turn feed a few spots of marine life. In this way, these surface dwellers are the base of the food chain, supporting countless marine life forms. But when phytoplankton die, their body can sink far below the surface, taking with them the carbon and the iron their living peers need to survive. And this is where whales comes in. Hunting at these depths, whales consume huge amounts of these phytoplankton predators. For example, species like a blue whale can consume up to 16 tons of krill every day, leading them to regularly surface and release a slick of feces red with iron. Through this cycle, whalers act as a living pump to bring iron from deeper waters back to the surface. However, if we take whales out of the equation, much as centuries of commercial whaling did, this natural system starts to break down. Over enough time, this broken cycle could lead to surface waters completely devoid of life, and similarly major problems for us to land dwellers. Phytoplankton's massive photosynthetic blooms produce as much as half of the Earth's oxygen. In addition to taking in iron, phytoplankton helps sequester a huge amount of carbon, an element we need to extract from air to address climate change. According to one report, phytoplankton can estimate According to one report, phytoplankton are estimated to capture 4 times the amount of carbon contained in the plant life of the Amazon. From these calculations, every 1% increase in phytoplankton population is the carbon capture equivalent of 2 billion fully grown trees spring into existence. While this while there's still debate about exactly how much of this carbon stays in the ocean long term, researchers are working to increase phytoplankton populations and bury as much carbon as possible. Some groups are doing this simply by sprinkling iron in the ocean. However, this approach is much less impactful than supporting the ocean's natural phytoplankton farmers. Whale poop's complex matrix of nutrients is a result of millennia of coevolution among these creatures, making it vastly superior to cheap man-made supplements. Right now, whale populations are still recovering from industrial whalings, but if we can help these species rebound through whaling moratorium, safer fishing and shipping practices, and clean up pollution, it will wonder for restoring this it will do wonder for restoring this nutrient cycle. Even when these newly protected whales die natural deaths, they will still be fighting climate change. Not only can whales' body sequester up to 33 tons of carbon at the bottom of the ocean, but their remain can also become an entire ecosystem, continuing to support life both above and below the surface.